Hi guys, welcome back to the Distinction Factory where we make our mark. And today we are going to be looking at grade 10 function notation while we focus on the y values of one graph at a time. So down here we have a little example just to get us into the hang of what they mean when they say things like f of x or g of x or h of x, for example. And you'll see this as long as you have any functions question. So let's say that I am referring to this graph here. That is a parabola, so we know that our equation should look something like ax squared plus q. And then if we are looking at this graph here, which is the blue graph, that could be a straight line, so it'll be y is equal to mx plus c. But because we cannot refer to them as parabola and straight line each and every time, what they do to make it a bit easier for themselves when they are giving us a question paper is they start to name the graphs as f, g, h, and so on. So let's call the parabola f of x. Notice that I took away the y and I replaced it with f of x. So what that means is that whenever I see f of x, that means that they're talking about the y values of your parabola in this case. And then for the blue graph, we are going to take away the y and call it g of x or g at x. And this now refers to the y values of your straight line graph. Remember that every y value, so every f of x or g of x, has a corresponding x coordinate. And you need to bear that in mind when we are answering these type of questions. So the first one says, sketch below are the graphs of f of x, which is ax squared plus q, meaning that we have a parabola. And we have the graph g of x, which is a half to the power x minus 4, meaning that it's an exponential. So if we are looking at f of x, let's identify which graph that refers to in our diagram. Here is our parabola. And then if we are looking at g of x, that refers to our exponential graph. So we are looking at this part here with that equation. So each time they refer to f of x, we look at the orange graph. Each time they refer to g of x, we look at the blue graph. So in this case, they ask us for which values of x is f of x greater than 0. So let's understand what this question means. They say f of x, and we know that f of x refers to the y values of a parabola. So we say y values of your parabola, and they say is greater than 0. So a little hint to you guys is that whenever they say greater than 0, don't read it as that. Rather read it as is positive. It's a bit easier for us to understand what they mean. Remember that numbers that are greater than 0 are positive 1, positive 2, positive 3, all the way up until positive infinity. So when they say greater than 0, we will just read it as is positive. When they say less than 0, so for example, f of x less than 0, then that means that we will read it as is negative, because any numbers that are less than 0 would be negative 1, negative 2, negative 3, all the way up until negative infinity. So in this case, they tell us greater than 0. So that means that we are reading it as is positive. So where are the y values of the parabola? Positive. And if we look at our general knowledge on our Cartesian plane, for positive y values, that means that they're looking at the y-axis as long as it's above your x-axis. So here's our x-axis, and we know that all of these numbers above it are like positive 1, positive 2, blah, 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 blah. So that means that these are all of our positive y values. And then if we want negative y values, then we'll look below our x-axis, because that's where your y values will be negative. So in this case, they want us to check where are the y values of the parabola positive. So let us look only at our parabola graph, which is this one here. And we are going to compare it with the points of intersection with our x-axis. So we are going to split our graph up into 3 sections, because this is where it intersects with your x-axis. And here is our next x-intercept. So we'll look at it there. All right, now that we have that, we can trace our parabola, which is this part, up until where I drew my line. And I can see that all of these y values end up being negative numbers because they're on the negative y-axis side of things. They are below the x-axis, so negative y values. This then does not answer my question because I want it to be positive. Let's go on to the next bit, which is in between our 2 lines that we drew. So here, if I had to compare it with my y values on my y-axis, I'll notice that all of these are positive numbers. So this does answer my question because I did want the y values to be positive. And then if I look past my second line that I drew, so from B going onwards, and I look at those y values, all of these y values end up being negative because they are below the x-axis. So this does not answer my question. The only part that does answer the question is the center part of our graph. Let me highlight that for us. There we go. All right, but we are not telling them the y values. We need to refer to the corresponding x values that the graph has. So here we know that this point of intersection has an x value of -2, and this point of intersection has an x value of +2. So as long as your x value lies in between that -2 and that +2, then we do have our graph being positive because the y values will end up being positive. So how will we write our answer? For 5.4.1, we will say that x needs to lie in between -2 and +2. Alternatively, you could write it as x element of circular bracket -2 because we are not including those values, and circular bracket +2 because we are not including that value. Perfect. Let's go on to our next question. Our next question is 5.4.2, and it says, where is f decreasing? Now remember that f refers to your parabola. And they want to know, where is the parabola going downwards? Where does it have a negative gradient? So let's look at the different sections of our graph yet again. And this time, I will include my turning point of the graph because I know that the turning point is where the graph stops going upwards and starts going downwards, or it switches direction. It starts, instead of going downwards, it starts going upwards and so on. All right, so looking at that y-intercept, or the turning point of the graph rather, we are going to compare all of our y values before the turning point. And we'll notice that the shape of the graph is increasing because we start off on lower y values and we end up getting higher to +4. That means that our y values have increased in this case. That does not answer our question because we want the y values to be decreasing. It needs to have a negative gradient. So let's look at the next part, which is from the turning point going onwards. So if we're looking at this part of our graph, we are starting off at +4 and making our way down all the way until -infinity. And you'll notice that the y values of that parabola end up being decreasing. They get lower and lower each time. So this does answer our question because this is where the parabola has a negative gradient. So how do we specify this to them? Remember that even though we are looking at the +4 and the -infinity, we have to give them the x values for those corresponding y values. So let's look at C. C is our turning point or our y-intercept. So that means it has a coordinate of 0 and 4. And then for this infinity part, it will go all the way up until +infinity on your x-axis because it's going to the right. And it goes all the way down to -infinity on your y-axis because it's going downwards. So our corresponding x values will be the 0 and the positive infinity. So now we just need to specify that to them. We can tell them that x lies in between the 0 and the positive infinity. Or alternatively, you could write it as x element of circular bracket 0. Here we use a circular bracket because we are not including the 0, because at 0 itself, the graph does not have a gradient. The gradient is 0 rather. It's only once it starts getting greater than 0 does the gradient become negative. And then we go all the way up until positive infinity. Here we use a circular bracket as well because we don't know the actual value of infinity, so we cannot include that. We have to exclude it, so we use a circular bracket. Join us for part 2, where we will be tackling the comparison of two different graphs, and I will show you guys how to do the vertical line test for that. Thank you.